This should be fun today. We got things to talk about, but I want to show you a few things as well. You know, it really pays to go back to the first papers that are produced on a particular topic and build your way up to understand a whole topic instead of just looking around for something topical that comes up. And it is about choline, but choline is remarkable in so many ways that in veterinarian medicine, it was long considered valuable back in the 30s and the 40s and the 50s and the 60s. And it was so impressive for so many different things. We're speaking guinea pigs and certainly rodents and mice, but cows, bovine, and porcine pigs. And now we're getting pretty close to humans. And so it wasn't until the late 90s did they find that it should be worth looking into. And there's a couple things that set them off. One was they found that those patients that came to hospitals that had what they call parenteral nutrition, they have a port put in and they're given nutrition, that choline was never included. And so they found all the patients that were too weak to eat and needed this kind of nutrition that they all developed fatty liver for the 2, 3, 4, 5, and the rest of their lives. So it wasn't until the late 90s was that corrected. And also when it came to pediatrics, neonatal, they found that in looking at a lot of postnatal, blood work and cord work and so on, and the formulas that were made for babies formulas, which we don't have much in this country now apparently, were devoid, empty, deficient in choline. And when they changed that, a lot of the kids' reaction, what they call spatial reaction and learning cognition, changed dramatically. So, and then they looked into the mothers and so on and so forth. But the important thing there was that making a change at any stage you're at, whether it's in utero, when the mother's pregnant, or postnatal after it's born, was tremendous. Now I want to show you something. It's just fun to step outside our backyard and to feed the turtles every so often. Here we go. All right. That's Roxy. Oh, sorry. See this guy here? That guy there, he doesn't have a name. He's, well, there you go, Roxy. Roxy's a veteran female. And this guy here, there you go, Roxy. This guy here is a male, and you can tell by the long fingernails he has. And he's pretty aggressive. He can get on with one other turtle. But if it gets to be more than that, because of his size, he's pushed underwater and he doesn't get his share. And so consequently, what he turns to is being pretty aggressive. He will actually bite the other turtles. And there's usually about 4 or 5 other turtles around here. See? There he goes. There he goes. He's not being nice. Hey, you can't do that. You can't do that. Hey, you stop. You stop. You stop. Look at that. Yeah, you go away. Some turtles need a timeout. You know what I mean? So here you go. Roxy, come on. I know. So back to choline. One of the new aspects of choline is that, when we look at autopsies of brains of those who have had Alzheimer's, dementia in general, we find that the brain is shrunk. That's pretty much not new, and you can get a lot of images on that. Certainly you can see it in autopsies, there's a brain, but an MRI while they're living, you can see it's a smaller brain inside, and that's how you check that. Here's another male showing up. He's new to the area. He's probably a little bit shy. See how much smaller he is? And what is profound is that choline actually is responsible for transporting in DHA, which is one of the essential fatty acids that you get from fish oil. So before we used to think about, have fish oil, it's good for your brain, especially DHA. So DHA is makes up 90% of your brain essential fatty acids. So that's EPA, DHA are your essential fatty acids. 90%. But of all fat in the brain, white and gray matter combined, it is 40%. So that's a big deal. So when you get choline deficient, you get deficient in essence of the transportation, the means of getting the DHEA into your brain. Slightly simplified, but not by much. And so consequently, what we're finding, and what is kind of the new edge, is brain shrinkage due to choline deficiency because it can't transport in DHA? That's amazing, because when you look at the brain, it's shrunk. The place that it shrinks the most, look at these guys. The place that it has shrunk the most is at the bottom in the hippocampus, which is the area which is responsible for memory. So what happens when people get demented? They forget. They forget their long-term memory. Actually, they have long-term memory. Their short-term memory is shot. There he goes. There he goes. He hasn't learned a lesson. Wow. Okay. And but that's the greatest shrinkage. So they find that it's the hippocampus is the area that shrinks the most. And therefore, those are the symptoms that we find in our partners, our parents, our grandparents, our great-grandparents. You know, this is the thing. It's like, so is there a cause and effect? Now they're all starting to come in, and I've run out of my turtle food. You know, it's you stay here long enough. Now there's 3 or 4 out there. Look at the heads on the water, and they're coming in. They'll go after my fingers for the same color. But this is what we're looking at. Sometimes it is pretty straightforward. We don't, I mean, you can be scientific about it, you need to look into all these things, but when the hippocampus, the bottom of the brain, so to say, where it's located, starts to atrophy more than the rest of the brain, those functions obviously are going to be the first to go. That's why they can't remember your name. Or in the case of my mother, she thought I was her high school boyfriend. Maybe that was a good thing, I don't know. But I thought I'd share that. And what I want to do is to go in and show you some of those illustrations and just a little bit of a data supportive sort of thing. Because what they find out is that dementia, Alzheimer's specifically, is associated with things like elevated homocysteine. It's a neurotoxin. And that was directly out of Cambridge, England, and they did it called Vitacog. They did vitamins, but mostly it was about homocysteine being associated with dementia. And that's treatable, is the point. So is brain atrophy. It's treatable when you start looking at, oh, it's choline deficiency, and choline takes in the DHEA, and the DHEA makes up 40% of all fats, 90% of the essential fatty acids for our brain. Maybe there's something we can do about that too. So let's go take a look. Okay, so the connection is that I wanted you to see if there are obviously variables that you can do to change this whole sort of slide down to dementia or Alzheimer's. One is about brain atrophy, very specifically, right? So specifically brain atrophy, shrinking of the structure, shrinking of, or having less of the acetylcholine, having less of the ability to all the things that choline does. And I'm trying to deliver to you the connection that choline is more responsible than probably anything else for brain atrophy, choline deficiency specifically, choline deficiency, because it deprives you of acetylcholine. Acetylcholine is a higher priority than phosphatidylcholine, which is the carrier of DHA, the essential fatty acids, into the brain. We're going to go more into that detail later, but I want you to know that concept. And so let's look at this. So this is what we're looking at. This is normal brain versus Alzheimer's brain. You can see that it's atrophied. And I want to point out these 2 areas down here. The hippocampus, that's going to be about memory and learning. And these are the faculties that you begin to lose in dementia, in mild cognitive impairment, into dementia, into Alzheimer's. Okay, so this comes from, as I mentioned, what they call the Vitacog, Vitamin and Cognitive Study, 2017. And it was really about a 10-year period of them really digging into it. It was really interesting. These are people that, especially the guy who was a head of, I don't know what the pharmaceutical company was in the UK, but he now works at Cambridge University and has his own research squad. That must be tremendously exciting to have both sides of that understanding down. But anyway, here's the PET scan, which is the glucose uptake of a normal brain and Alzheimer's brain. So we see it in 2 ways, right? We see that there's parts that are not functioning in the sense of taking up glucose, the tracer of glucose. So mild cognitive impairment confronts 5 to 20% of Americans age 65 or older. My guess it's a lot higher. And it's just tremendous they did this, and they're saying one of the risk factors. And so identifying risk factors that can be treated very easily. So this isn't like, oh my gosh, this is like a PhD. You have to, go to school to learn to do all this. No, not at all. Not at all. There's simple things. So it's like raising your hand, more or less. The risk is higher among people who have high blood level of homocysteine. I'm going to show you basically the last 10 or 15 patients, clients that I have seen. High homocysteine and MCI, mild cognitive impairment, both predict a higher risk factor higher risk for developing full-fledged Alzheimer's. You ought to look up that study. It's just fun to read too. Okay, so this is basically a spreadsheet of a portion of, randomly chosen clients that I've seen. What I did is I sorted all this. I'm not going to show you all their labs, just a little snapshot here. It's not that it's private, it's just that it's too much information to go over right now. And so I sorted this by homocysteine, highest versus lowest. That's really all you need to know. And I want to see, does anything else fall in place? We just stated that homocysteine is a high risk factor for Alzheimer's. What are one of the things that helps homocysteine go down? Choline, but also folate and B12. So they knew about folate and B12. They didn't test for choline, and they knew about essential fatty acids, that is, fish oils, EPA and DHA. But they didn't know about the choline and DHA connection, to be elaborated on later. So there's homocysteine. What else falls in place? So these are the people that have the highest risk factors for Alzheimer's. And they're all men and women from, in this particular swath, between mid-40s to mid-70s. Really interesting. And so what you're looking for is a range of, ideally, think of 6. That's the middle. 5 to 7 is the sweet spot, so call it 6. Clearly over. 18 is like 3 times that. And so down here is rather normal. So you have, over down here, it's okay. So what else do they have in correlation? Well, these people who have terrible homocysteine clearly have terrible fish oil. EPA, DHA. They're what they call the EPA panel is just your EPA. The ratio of omega-6 to 3 is terrible. 17, you want 1 to 1. There's 17 to 1. So you can see other factors. Insulin resistance, I would say so. There's their insulin is 26. What do you want it to be? 2. You want it to be 2. We can go into, HOMO-IR is basically saying insulin resistance. It's a formula, but it's the same thing up here. So that's what we're looking at there. So we got that as a clear, and you can address that. You can go get your own blood work done. You can go find out what your homocysteine level is. I would at least start there. So notice where brain atrophy is happening. This is what I'm trying to point out to you here. Is healthy brain versus for Alzheimer's, about the 3rd or 4th picture I've shown you of this. There's a hippocampus down here. Brain atrophy and advanced Alzheimer's disease down there. Notice that it is not symmetrical. It's not always bilateral. In some cases it is somewhat bilateral, but it's usually worse on one side or the other relative to the hippocampus atrophy, which means relative to what they can remember or not remember, or learn or not learn. Okay, so the hippocampus is a structure deep in the temporal lobes. These are temple, right? Temporal lobes here, so it's deep down there. So give you a few other shots there, kind of at the bottom of your brain, off to the, in there. And so atrophy of the hippocampus corresponds to loss of function in dementia and Alzheimer's. So the hippocampus is deep, and it has to do with learning and memory. Now it's going to get interesting. Let's return to the study that showed us about choline deficiency in the first place and how it affects humans. And that was from Dr. Stephen Zeisel up at the University of North Carolina. Here was his experiment. I'm not going to go deep into this, and if you want to look into it, it's called Sex and Menopausal Status Influence on Human Dietary Requirements for Nutrient Choline, 2007. He's elaborated on it, and it's pretty much a first chapter in a book. He's done a number of really nice studies. So what they did is they had 57 people, men, women, they were premenopausal, postmenopausal. He brought them, made sure they all for 10 days were at the level of what they call adequate intake, which was set by the, in essence, NIH, Institute of Medicine sets that in the United States. So they were all at the same place, and then he dropped them down and made them deficient, depleted them, if you will. He depleted them for a month and a half and then brought them up step by step by step until they were back to 550. So 550 is the level for men. It's the level for lactating women, so it's the highest level. And though it isn't stated, it really should be the level for postmenopausal women. So it's kind of the highest level. But adequate intake means if they have this amount, they should never be deficient. And I'm going to show you, and I've showed you before in past videos, and here's a link above, of why that's not quite the case. So some men have higher choline requirements. So what we did is, this is from the study now, they're saying from that 550, right, that from the 550 milligrams of choline, some men, here's men up here, men, postmenopausal women, premenopausal women, still didn't get enough choline. They needed more. They needed more. So out of 6 out of 26, that's a little over 20%, a little over 25% still didn't get enough. Postmenopausal women were fine, premenopausal women were fine. But when they depleted everybody, who suffered the worst? Clearly men suffered the worst. 20 out of 26, so that's about 80% were hurting. What does that mean, hurting? It means they had muscle dysfunction, and you can tell that by labs, CPK, cholecystokinin, and the level has to be 5 times higher than their baseline, than when they came in, 5 times higher. So it's not a little bit, it's a lot different. And so for liver function, it means their liver enzymes, liver function tests, have to also increase 5 times from their baseline. So that means they did have dysfunction. 6, however, were still fine at that low level for that period of time. And everybody, 100% of everybody had elevated uric acid for long after the experiment was over. Long after the study was over, it took them a long time to get back to baseline. And why is that? Because it affects your immune system and it kills your lymphocytes, apoptosis, which is cell death. So I've talked about that before. That's why I'm going quickly. Here, I've shown you this before, but I'm going to show you this a little bit different now. This is the recommended AI levels, right? Men 550, notice men over 70, 550, men 550, women, which are premenopausal women, 425, pregnancy is a little more, 450, and lactation 550, co-equal with men. So why is that difference? In this pretend world of all women are the same, which they clearly are not, is that women can make their own choline because they're high estrogen years. It doesn't exist for all women, but most women, so that's why that's lower. And this is where we got that Institute of Medicine, so it's pretty straightforward. And these were the averages of the kids, which were the only ones that were, quote, good enough. They were all deficient. So men were young men were deficient, women were deficient, premenopausal, pregnant women were very deficient. And you notice the pregnant and lactating women were basically equally deficient, but the requirements for lactating women, breastfeeding women, was a lot higher. So let's look at this a little bit differently. I just want to say the conclusion to that study was that of a daily intake of the AI, so everybody following directions and taking their AI, they found that it was still not sufficient to prevent organ dysfunction of 19 of the subjects, which were men. So they were hurting. So it still wasn't enough. So 19 out of 57 people, a third of the people, AI, the Institute of Medicine, NIH, amount of choline was not sufficient to make them not have 5-fold increase in their various lab problems, okay? That's amazing, a third. Okay, so now we're gonna look at this a little bit differently. What I did here, took that same picture you saw, and I said, all right, here's how far below. So they're, for premenopausal women, for instance, men, sorry, this is men, young men, they had roughly 400, and they're supposed to have 550, so that's roughly 30% below the AI. Or if you want to say it another way, they had 70% of what they needed, they were still short. They're not making their own choline. So premenopausal women that can make their own choline were 60% of what they needed. So we're assuming that they made up the difference, which isn't true for everybody. And now same with the lactating women and pregnant women, they were equally, they had the same number that they were taking in, but because the demand was higher, the requirement was higher for lactation, they were about 40% deficient, 40% deficient of what they're supposed to have. So we're hoping they can make some up themselves, but still they're deficient. So that's taking that into consideration as well. And of course for older men, it says men over 70, they were hugely deficient. Look at that, they're getting half of what they needed. So the question then is, if men were deficient when they were young, younger than 70, and they're really deficient when they're older, what does chronic choline deficiency look like times 30, 40, 50, 60, 70 years? That's a problem. Do you think that has anything to do with brain atrophy? I'm thinking it does. All right, so now we're going to go back to that, and I'm going to plug in those levels of people into, like, if they were doing the experiment. Where are they, right? Remember the baseline, then they depleted them. Well, here's where men over 70 and premenopausal women both had about the same average intake level, and this was their level. They were at 50%. So they would have really been terribly hurt in this particular experiment. This is now lining them up. They wouldn't have worked out very well. A little higher were pregnant and lactating women. Their average was 337, remember? They're only getting 75% of what they needed. Do you think that's a problem? Do you think that's a problem for the fetus? Do you think that's a problem for the child that's born, prenatal, postnatal? It is a problem. And here's where we're getting that information from, of course. Chronically choline deficient men are. So there we go. There's the men under 70. They are about 30% deficient. There's the men over 70. They're over 50% deficient, and they're not making their own choline. So what do you think would happen if you were chronically deficient in choline for nearly all of your life, except for maybe the first 10 or 15 years? Stretch to say if it's 20. It would not be good. So now I plug this back in,
Remember, we're looking at the data from that experiment, and they're saying of all the men's section now, at this level, this is how many people, this is how many men were still having dysfunction. So that means 6. That's O times 5. So 5 still, at 550, still had a problem. At, that's over 550. At 550, another one, so it's 6 together. At 412, which was the 75%, there were 3 that were deficient. So when you add up all of those above 275 milligrams, which is, I'm trying to average out what the men had, 50% of all the men in general now in the United States are deficient, and they would have dysfunction. They would have liver dysfunction, and they would most likely have muscle dysfunction. What about women? How chronically choline deficient women are. Here we go. So for average premenopausal women, below what they're required to get, that's AI. AI is a bottom line. They are nearly half. They're about 40% too low. They're only getting 60% of what they need. Women who are pregnant are getting 75% of what they need. They're still low, still deficient. Women who are lactating, who have the highest level, 550 milligrams per day, they're now down 40%. That's huge. So premenopausal, pregnant, and lactating, the 3 levels of choline requirement for women. So postmenopausal is suggested to be 550, which is the same as men. Okay, here's what it looks like for postmenopausal and premenopausal, their data. How many people were deficient? So what I threw in, right, the 337, that's what women had. Anybody, above that were certainly deficient. So I'm showing you here where out of the postmenopausal women and the premenopausal women, more than half were deficient. What do you think that lifetime deficiency looks like? Phenomenal, eh? So I superimposed them back into that study, saying here's the levels that NIH, the Institute of Medicine, says that we all have in the United States. Why would they be, if anything, they would be better numbers than the reality is actually. So fewer menopausal women were deficient due to being able to make their own choline, of course, and that's assuming they don't have the SNPs that we've talked about before, okay? That was another video. And there you go. That's the big deal. We'll continue on the idea of brain atrophy and DHEA and phosphatidylcholine and choline. It's very important, and I'm hoping you follow on this. Till next time.
So what you saw basically is how we get older. And by the way, in case you thought that that particular process started at age 70 or something, that's Roxy, no, it doesn't. It actually starts, it actually starts at age 20. So your choices of being, and the reason I'm talking about choline different than any other nutrient, because it has so many different functions. And it really is a grand slam in the fact that it talks about methylation. I've talked about that before, and it's about making phosphatidylcholine, which is what I call the wrapping of all the cells, which is really important. And now really, and of course, making acetylcholine, which is a neurotransmitter for muscles and for your brain. That's been pretty much the story for the last, well, actually not up till now, but the last 60 or 70 years. That's been it. And everybody believed that, even back in the 20s when they started noting that phosphatidylcholine, lecithin, was in the brain, and the lecithin was in the liver. And then when people don't get enough of choline via phosphatidylcholine, they suffer liver damage, muscle damage, and what is only now recently being studied is brain damage. So they know that there's a correlation of diminished acetylcholine with dementia. That's pretty much across the board, and there's many ways to get there. But the fourth part of it being a transporter for an essential nutrient that provides the, if you will, the building blocks, the actual physical occupation fat of the brain, that's a big deal. And let me just help these guys out for a second. There you go. They like going, once they get the message that they got free food in the water and they don't have to jump for it, they're all over the place. There they go. And they can swim fast. So these turtles, by the way, are yellow belly sliders. So these are the little pet turtles that used to be sold in pet stores. And now they're big pet turtles. Well, so to say. And this is kind of the dominant turtle down here. So this is the native habitat. There's two little males over there. Native habitat for yellow belly sliders. Whereas if if these little kids buy them in the store and they release them locally, it ends up being an invasive turtle. So it's fine to do that here with this turtle food, and they love it, and they need to learn to get on. But so anyways, acetylcholine is so impressive because I think the deficiency, which is really over the last 70 years, we don't know before that, correlates with the obesity epidemic. It correlates with the huge incline of chronic diseases, certainly Alzheimer's, certainly dementia in general, but really it's much more, it's bigger than that. In the 50s, they studied choline deficiency as associated with cancer. Those papers are old, and I'm sort of looking into them because I think that's really interesting. But I thought that it was worth sort of looking at this whole choline deficiency in a new way. I don't know where turtles are relative to choline, but I'm sure they have I'm hoping that they get their part. They'll get it through animal foods, from the shellfish they eat and the fish that they eat and the turtle food we give them. Till next time. So if this is something that you're interested in, that is a topic that I obviously go deeper in terms of labs, in terms of how to do it, in terms of why you would want to do it, various topics, as you've seen that I've done in the past, then please let me know below in a comment. Till then.